Okay, so welcome everybody. Thank you all for your interest in our tutorial, Better Teaching of Business Statistics. So what can you expect from our session today? It won't be an introduction into statistics in business, finance, or administration. I'm also not going to tell you how to teach because you are the teaching experts. My goal today is to inspire you on different levels how to improve the way you teach with data. There are many factors that can make teaching better. We strongly believe that teaching with data requires the use of software. So tools are definitely one factor. In a minute, I will show you some cases demonstrating how to use JUMP so that you can see yourself what's unique about our software. As far as time allows, I also have some quick examples to show you what else students can do in JUMP. A second factor are resources, including demos, exercises, courses, and so on. They can make the life of the lecturer or course developer much easier and allow students to help themselves. With JUMP, you need neither to teach the software nor to worry too much about troubleshooting of the students' technical issues. Instead, teach students to learn from the JUMP help, from webinars, e-courses, or textbooks, and maybe turning some students into lifelong learners. Just a side note, the third factor is, of course, teaching methodology. Keep in mind that JUMP is perfectly suited for active learning, blended learning, or flipped classroom, but I leave this transfer to you. And after wrapping up, we will hopefully have some time left to answer your questions. So in order to show you how easy it is to explore and visualize unknown data, I open a very small example from the 500 sample data sets in JUMP, which is called birth, death, .jump. So this table has crude birth and death rates from 2009 for 74 countries. This table has 4 columns or variables. 2 of them are categorical and 2 are continuous. So to explore these data, the student has to choose where to go: more graphing, like bubble plots, scatter plots, surface plots, tree maps, and so on, or more analysis. And here the question is univariate, bivariate, or multivariate, different options for that. So let me start with an analysis platform for univariate analyses. So the way to start a platform in JUMP is quite intuitive. It's everywhere the same. So you launch the platform, you get to this window. So there you cast your variables into roles. They should play in this analysis, and then action. And this is the result. So here for the categorical data, we see bar charts for country and region. And for the continuous numeric data, we see histograms and box plots, plus some statistics shown below. So country looks good, just 1 row per country. So this is good to know, but not that exciting. Let me remove that output from the report. And statistical discovery is really a journey, and your main friend on that journey is the red triangle on jump reports. So if you look at death, for instance, and the question comes up, so is this data from a normally distributed population? So maybe you want to explore this. You look at the red triangle. One option is to get a normal quantile plot. And with this curve here, maybe there's some doubt on that assumption. Or you ask JUMP to do a continuous fit for you. You can ask for any type of distribution, or ask JUMP to find out what's the best distribution fitting our data. So the winner is a log normal distribution. So we see this here, and it's also added as a green curve to the histogram. I can also check the normal for comparison reasons, and we also see, and you can read below, that this is doing not that good as the log normal. I can go down and look at the fitted normal. If I still have some hope, maybe I can ask for a goodness of fit. And this p-value is so small to reject the null hypothesis, which is also mentioned below, and this is the data are normally distributed, but I think this is enough evidence to reject it. Yeah, we also have the red triangle here, so I can add other summary statistics, maybe skewness, kurtosis. So we already see that we have skewed data here, and the statistics are added to the summary down here. If you want to get them as defaults, you can add them also in the preferences to customize your JUMP installation. Another way to work with reports is the right click. Yeah, so here we see this red thing, and if you want to know what it is, maybe we can drop the help tool there, and the help tells us, oh, this is a shortest half, the shortest distance covering 50% of our data. If you want to get rid of this, maybe to get this into a publication, but you don't need this information, you can customize the output at any point, and we can remove the shortest half and the confidence diamond, and now this looks much easier, and it's changed. So that's very easy. You can also right-click everywhere else. So here, if you want to visualize the AIC corrected values maybe for different distributions, right-click, make this table into a JUMP data table, and then you can use this for further analysis or distribution. We also have these guys up here, which look like some outliers. So it's the third row. If I want to know who this is, I can change the variable country and add the label state on that variable. So if I now point to a data point, I see that information, which is the country information. This is Angola. So that's maybe an outlier, and maybe we have some other outliers down here. So I can select them here. And if we look at the data table, we see that these three rows are also selected on the data table. So we have Angola selected and two others. And now I could exclude them, or handle them in a proper way. Now, if I want to store maybe the information that these are outliers, maybe for further analysis, so what I can do is from the rows menu, row selection, and then name selection in column. I name this outlier death. So this was already entered earlier, so it's stored here. Outlier death, question mark, and then click OK. And then a new column is added, and there's a 1 if there was a suspicious value, which could be an outlier. So this is stored and could be, I could come back to that information later on. So you see already that everything is linked and connected in JUMP. So if I click on Europe, I see the birth rates for Europe and also the death rates. And if I click on another region, Africa, for instance, I can easily see the difference in birth rates by clicking on Europe or Africa. I can also multi-select the high death rates, and you see how this dynamically changes all other outputs. And this is maybe interesting. So just taking the high death rates countries, we see there's one group of countries with high and another group with low birth rates. Okay, so let us move on to another analysis platform for bivariate analysis, fit y by x. So here we are interested in the relationship between two variables, maybe death rate depending on birth rate. So what's the relationship here? So this already tells us we will get a scatter plot from that analysis, and here you go. So this is our scatter plot, death versus birth rate. And now I can open the red triangle and see what are the options in this analysis context with two continuous variables. So for instance, if I'm interested in correlation, I can add a density ellipse, bivariate normal ellipse, and this also tells me about the correlation coefficient down here. Let me move this one and let me add a line. So what about a line? You can easily see that a line is maybe not a great fit to our data. So we get an R-square adjusted of 10%. But I can add another one. So let's try maybe a quadratic polynomial fit. And here we get an R-square of 36%, much better. So this is the formula of the fit, our very simple model we build for these two variables, and then we get all the parameters below and also an analysis of variance table and all the details. If I'm more interested in the polynomial fit, I can also open that red triangle, and maybe here I want to look and check some diagnostic information, so I can look at different residual plots which are added to the report. Okay, so let me carefully remove this one here. So keep in mind, so JUMP is context dependent. Yeah, so it matters what type of data you use. So if I use the same platform and now I start the same way, so I'm interested in death, but how does it depend on region? I get into a different analysis context, which is a one-way ANOVA. Yeah, and opening the red triangle, you see immediately we get other options matching this context better. Yeah, so here I could ask for means and ANOVA output. I can compare means for different groups. Groups are the regions in this case. And I can compare means, maybe using the Tukey honest significant difference test. And again, we get some graphical output. And that's a principle in JUMP, that you get a lot of visual output, giving you answers, giving you some hints, maybe also warnings. And you don't need to look into all the details below and the statistics. Of course, you get connecting letters report and all the details below, but a lot can be answered directly from the visual report output. Let me show briefly another tool, which is Tabulate. Tabulate is an interactive tool to build summary tables. So I grab these two variables, I choose some statistics to show, I group this by region, and maybe I also want to have some visual representation here, and when I'm done, I click Done. And you can easily build summary tables of any complexity. And look here at this panel on our data table, so I can save any report at any stage by choosing Save Script from the top red triangle and then save this as a script to the data table. I name this My Tabulate, and you see I'm done. And by clicking here, I can just run this and I get back to the same interactive report, and then I can further analyze and start from here. Another common thing you can do, and your students typically need to do, is get this into on a slide or into a document, maybe a paper or anything. So to do this, you need to get the selection tool or just press S. Yeah, then the cursor changes into a fat plus, and then you select what you want, maybe this, your copy, and then you go into Word, and here the trick is not just paste, but use paste special PDF on the Mac and enhanced meta file on Windows. And then you get a graph you can easily resize and zoom, and you maintain highest quality on that image. Okay, so that's a common thing here. Let me close this one. And there's a big brother of the Tabulate tool, another interactive tool, which is the Graph Builder, to build visualizations interactively, not tables in the first place. So here, maybe we could look again into death versus birth. And we get this. I can take region as a grouping variable and check the preview. So what do I want? Maybe wrap the regions, or use just coloring one smoother, or overlay different smoothers overlaid for each region. And we can select this here. I can also change and choose a contour plot, or I can choose ellipses or regression lines. I can switch the confidence interval for the fit on or off, and I can also add the data again. So let me start over, because we have one special variable here, the country. And if I drop country on map shape and also show them the missing countries, so now I can visualize death rate geographically by country. So here we see that Angola, our outlier, has an extremely high value for death rate. I can also take the magnifier, and then I can zoom in and out. It's also this, so you can zoom in and out, and by right click I can also add the background map, so to add some water to the picture, and when I'm done, I'm done. And then I can move this around, and you can change it as you need it. So this sample data table, as many other sample data tables, has stored scripts, and one is the clustering using hierarchical clustering. And you see this dendrogram. You can change the number of clusters dynamically, and this shows us which countries fall into one group, into one cluster. And we see in this case Bulgaria and Russia, and Kenya and Madagascar, and Nigeria and Zimbabwe are grouped together on that detailed level. So it's easy just to open some sample data files you're interested in, and then just check out the stored scripts you find there. Okay, so let me move on to the next example. And this is more about predictive modeling now. So the situation is, let me open this data set. The situation is that a mobile carrier extracted information from a customer database. And marketing wants to understand the main drivers for customer loyalty and predict the likelihood to churn. So here we have target churn. So we know the churn behavior for more than 4,000 customers. And for all these customers, we also have some predictors, some information available, which allows us, if we know this information about others, to predict the likelihood to churn. So that's the story with this data set. And to save some seconds, I just follow some stored scripts here. So you already got an idea how to click this together. And I will come back to how to do it when we come to modeling later. So here, this one creates an intermediate summary table. So for all the states, we get the number of rows and also the number of churned customers. And that allows us to calculate the churn rate, which is this divided by the total. And using that one, now we can again visualize churn rate by using the shapefiles for North America, all the states, and this tells us that, oh, it's maybe a good idea to focus a bit on Florida to avoid churning in the future. So let me close this again. So here's also distribution output. I can select churn and then look at my predictors and see if we have any patterns. So here maybe we see call quality is maybe an indicator. So if the customer complained, this is complaint code. If they complained about call quality, then this is maybe a good reason to churn. If the customer called the hotline and said, hey, I will move, that's maybe not a reason to churn. So we can easily see this here. Also, higher average days delinquent. So the carrier is waiting for the money after sending the invoice out more and more and more days. So the longer this delay is in payment, so the more likely gets the churn behavior for that customer. So that's what this distribution output tells us. So we can also use Grappling in many different ways. So here we see the difference between gold and silver customers. There are much more silver customers, but for silver customers, there's less churn than no churn, but for gold, so they are more churning. So maybe the gold tariff is maybe a bit too expensive, so that we have a higher churn rate for gold customers. I can also look at a parallel plot like this, and again I can select curves on the parallel plot and average days delinquent. By selecting the high ones, I get more red, and selecting the low ones, I get more green, no churn. And here's also a data filter in place, so I can also look into customers called with different complaint codes, issues with call quality, issues with the check account, and I get different pictures, and I can look at subsets quite easily by using a local data filter. Okay, so now it comes to prediction, and the question is, what are the best predictors in this case? So an easy question, some screening can be done by choosing screening and then predictor screening from the Analyze menu. So my response is target churn. That's what we are interested in, and these are my predictors. And I click OK, and I get a first ranking and idea about what are the most important predictors predicting or maybe explaining target churn. So average days delinquent is indeed one of the most important ones. So that's maybe a result from here. Also percent increase, MOM, month-on-month, and complaint code. So here is a simple model just using a few predictors. So from the top, I don't know, maybe the top 4 predictors from that screening, and we can build a logistic model using the fit model platform. And then we see the summary, the effect summary. Again, we see average days delinquent being most important. Now we can look at parameters and the model effects, but we can also look at the profiler to understand the model better. So here we see the settings of our 4 predictors in our model, and then we see the predicted target churn on the left. And now you can easily do what-if questions. So here we see if the percent increase month on month goes up, so then the likelihood to churn really goes down. So you see 40%, 20%, 10%, and here it's almost 0. So if the customer is spending more and more, so then they are maybe not going to churn. But if this average days delinquent goes up, you see you get a churn rate. If you get to 70 days, maybe you get a churn rate of 97%. With the other factors set to these values in red. And you can easily ask what if, and what if the billing problem is, or complaint code is not a billing problem, but maybe call quality. So then you see that you can bring the likelihood to churn rate again up. So that's what we already saw earlier. Okay, so next, there are different ways in JUMP to build predictive models. This is one, a decision tree, and what we have here, maybe I'm not sure if the validation is used. It is, so I can here click go, and then JUMP uses one important variable from our data table, which is this subset. And subset splits the data into 3 subsets: a training set to build the model, a validation set to pick the best model, and then a test set to do some honest testing. And the test data are not used on model building at all. And there's an easy way to get such a column in JUMP. So from the analyze model predictive modeling, you can choose make validation column, and here you see the options. You can specify the portions for the subsets, and then you can have a formula on that column, so to reshuffle the sets every time this one is used, or have it fixed. And this one has been produced 60-20-20, and it's fixed. And this is used here as a validation column. So now we see that the model is built and the R² goes up, and the model gets complexer and complexer. But if the validation R² goes down for 10 splits in a row, then JUMP goes back and says, okay, that's our best model based on the validation subset. And we also see that the test data in orange here. And if you look at statistics, show fit details, you typically look directly at the test data, the test scores. So this is misclassification rate, and we see a misclassification rate for the test data of 20%. So that's maybe a metric you can use to compare this model with other models also built in JUMP. Other models include multiple trees, so random forest or bootstrap forest. Again, the validation split is used, and you would directly you look at the test output, and here we have 18%. So we have a slight improvement compared to the simple decision tree. You can also build neural models. So here again, so this is one type of neural model in JUMP, and this is the test output. Misclassification rate 26%. So this is not an improvement. So it's not a better neural network yet. Yeah, I can show you the diagram. So here we have 2 hidden layers in this network, and you see how this finds the way to our response, to predict the response. And one common feature you have on all modeling tools in JUMP on the top or red triangle is to publish the prediction formula, and this gets you to the formula depot, and the formula depot takes a prediction formula from any model, and from here you can export scoring code. For instance, C code, Python code, SAS code, SQL code. Now, to implement this model in your environment. That's the formula depot. Now, so you can build many different models. Another option is everywhere to save the prediction formula, and that's what I already did earlier. So here for my logistic model and a decision tree random forest neural network, I have the prediction formula saved. Yeah, so I could take them and export the scoring code, or I can again ask what is the best model so far. And there's a model comparison platform in JUMP to answer that. So here I can maybe sort by generalized R square, and we see the winner is the bootstrap forest model based on the test data, and that's important. Okay, so let me briefly show you the last example here, and this is about a typical thing, at least typical in the real world. Data are not perfect. Data are not ready for analysis. So you need to do some significant cleanup. Typically, you get some messy data with outliers, missing data, and so on. So here we have some credit risk data. So this is the response, bad. It's a bad risk or good risk, bad or good, for a certain customer. Yeah, and then we have customer information down here. And you already see the blue cells with the dots. These are missing data, missing values for continuous variables. If you see an empty cell, that's a missing value for categorical variable. Now, if I run distribution, so this already gives me some hints about potential outliers. We can easily see on the box plots. But there are also some dedicated tools to explore outliers. So that's on the screening menu, and then explore outliers. So here I take all my continuous variables in here and check for outliers. So I can check the quantile range outliers. So I specify a factor Q, and then Q times the interquantile range added to the table quantile, which is 10% and 90%. And then we get these values, which are even far beyond that region. So these are potential outliers. And if I make this smaller, I get more outliers, of course. If I make it bigger, I get less outliers. And then I can choose the outliers and decide what to do, exclude them, mark them, color them, different ways to handle them. Another option is to ask for multivariate robust outliers. So this gets us to the Mahalanobis distance plot we see for all our data points. And then all data points which are high above this upper control limit, they are suspicious outliers. They are really outside of the multi-dimensional main cloud of our data. Now, for missing data, you can visualize the missing data pattern. Again, I select the continuous ones in here, and then I get some visual output, maybe a tree map, and 0, 0, 0, this is all good. 0 means there's a value. But there are also other patterns. 1 means at that position in our variables from left to right, there's a missing value. And then if the frame is bigger for one pattern, then you have more occurrences of that pattern. And if it gets more red and red, then you get more ones in that pattern. So you have more holes in that in these rows. Yeah, again, you can also select frames here, certain patterns, and then handle them somehow. But on the screening menu, there's another tool set called Explore Missing Values. Same procedure. I just get the continuous ones in here, and then you see the missing value reports. And there are significant numbers of missing values for certain variables. Load is the only one without missing values, but that divided by income, so maybe the income is not given by the customer, and then there's a missing value for that information. And here you can look into different ways to explore this. So I can look at some clustering. I can also do imputation and say, okay, and now you see all the blue cells, the empty cells are filled and values are imputed, and here you can read what happened. And if you don't like it, you can also undo this step. A nice way to use this information, if a missing value really carries some information and can maybe improve a predictive model. So a nice way is a feature like this one. I don't have the time to show you the differences and how it works, but for partition, let me relaunch this analysis. So here we see our variables, but there's an option called informative missing. And informative missing can really improve your predictive model if the missingness has some information, has some value, is telling you something. So there are many ways in JUMP to handle messy data, to explore them, and then to decide with some information and a good information how to handle them, what to do with them. And that can only be done in JUMP, excluding that there are many ways to act on that information. And if it carries information, real information, then informative missing is really an interesting feature you could try out. Okay, the next very quick examples are not about how to do it in JUMP. This is more about what a student can also do using JUMP to give you some more ideas about platforms and analysis types you find in JUMP. It's much more than introductory statistics and a bit of modeling. No, it's a lot of modeling, powerful modeling, but also more methods like this one here, uplift modeling. And this is a sample data set. So here the question is, can we identify characteristics of customers, individuals, who are likely to respond to an intervention. The intervention is a promotion in this case, a campaign. And our response, what we are interested in, is did they purchase or not? And here we see the characteristics. So the question is, what type of customers are most responsive to such a promotion? And this can be answered by uplift modeling. This is very similar to partitioning. It is some kind of partitioning. And here I can split, and we are looking for the highest differences. And here we see a difference, the highest difference for the gender female, not for male here. This is really flat. So this means send your promotions to female customers. The next step tells us, okay, again, the highest difference is for the hair color brown, black, and red. This is much better than the hair color blonde. Another split. So if blonde, then approach the young customers, age below 42. Not this one, which would have even a negative effect. So here the promotion would have a negative effect. So that's uplift modeling, which is a quite useful tool in marketing and planning campaigns. For predicting on time series, here's another data set. So we have some data in time, and our data are about numbers of electrical workers in thousands. And the platform to use here is specialized modeling time series. So data is our time, and number of workers, that's our Y. And here we see the basic time series output. But from here you can build a model, ARIMA, seasonal ARIMA, or you can build a smoothing model, use a smoothing model to forecast. So the development of numbers of workers, maybe using the Winters method. And we get the output here. And here you see all the parameters, the estimates, and the model summary. I can also try another one for comparison reasons, maybe seasonal exponential smoothing. Okay, let's apply it. We get more output down here, but we can easily compare both models. And so far, so this is telling us that here the AIC is lower for seasonal exponential smoothing. So according to AIC, this one is doing better than Winters method. Okay, let me close it. Survey analysis. So here you typically get a lot of categorical data, and here you have a survey asking for consumer preferences. And here we see all the answers from the survey. So it's about salary group, job satisfaction, but also about brushing teeth. So when do you brush your teeth? After waking up, or after meal, or before sleep, or both? So there are really some complex answering schemes which can all be handled by our very flexible categorical platform. And just to give you a flavor of that, so here we see some outputs. So we see this share chart down here, which directly shows you the portions of respondents who agreed or disagreed to that statement. The statement was, I'm working on my career. And you see that the younger ones more agree on that, what makes sense. And you can also look at other statements here. So brushing indicator group, this is more complex because respondents can specify one, several, no answer from one group. When do you brush your teeth? And also that can be shown quite easily. For any output you get, if you are interested maybe with sample data, how was this created? Go to the redo menu and then relaunch the analysis. Yeah, and there you see how this was created and configured. So here we have age group down here as a grouping category, and then we have an indicator group set here. So by this button, indicator group, we also have a drag and drop tool here to come up with tables of any structure. So this is really, really flexible. Then in many cases, you want to test for preferences, consumer, customer preferences. So here's about candies. Yeah, and one way to do this is to use a choice design, discrete choice design, and then conjoint analysis, which is both available in JUMP. Yeah, and another more a newer approach is MaxDiff, where the respondent chooses the best and the worst option from a certain choice set. Yeah, and by creating this design, yeah, you get a table. Yeah, and here you see that Lily gets the choice from these 4 candies, and Lily said Hershey, that's the worst, and peanuts, M&Ms, that's the best, I like most. Yeah, and there was another set for Lily, and also other respondents down here. So that's the design. We also have the responses in here. Yeah, and the design tool in JUMP also adds an analysis script to the data table. So as soon as you have all the responses collected, you can click on that one on the analysis, and then you get the output, and you see that Lily was a good representative person maybe for that group. So plain M&Ms, and also peanut M&Ms. So they are really on the top of this list here. Okay. And finally, a last thing. This is about text processing. So here we have pipeline accident reports or maintenance reports. Yeah, and in this data table with 1,700 rows or reports, there's an authorizer title. So that's the title of the person who filled this information. Yeah, and you see there are many different versions specifying the same, basically the same title. So how can you recode these titles? I already said, so here is a platform available on the columns menu called Recode. So this allows you to recode the titles one by one. So this one here appears 82 times, and I can replace this one by another version of that title. But I don't want to do this for all titles, and you see there are many different ones. So there's an automatic way to tidy this up, and that's called group similar values automatically by taking maybe a certain edit distance or some limit in here, and then JUMP does the grouping automatically for you. And here you see the result. And here, for instance, this is one group, and we see, oh, that's just a misspelling. So I can right-click and remove this one from the group. I can say, okay, this is just a misspelling here, and I correct it, and now it's added back to the group, but the wrong version is gone. I can also say, okay, this is the normal one, this is the one I would like to see for the whole group. I can make this a representative and so on. So this is really handy. It can save you a lot of time cleaning up your text data, categorical data. And another column has text information. So this is called narratives, and we have just unstructured text. So any stories, comments, whatever, and what to do. yes, you can analyze this in JUMP, and you can convert it into numerical representations for further analysis and even model building and prediction. And the tool here is called Text Explorer. So I just use the defaults, this column, and now I can analyze what's in here. So I see all the terms, the verbs, and I see the phrases, which are typically in the text here. And the next step is what I can do. I can add a word cloud, so to see what this is about, and release. What release? What is release? Show me the text. Yeah, so still JUMP. Everything is connected, and you can easily get the context information at any point. But this goes further. So you can also go and proceed into analysis. So I can choose latent semantic analysis, what can be compared to principal component analysis in multivariate statistics. And here I have some dimension reduction. So I look at the two-dimensional document space and two-dimensional term space, and I can pick some terms here, and I see this is about this corner, and this space is about pipeline pressure, leak line personnel. Probably maybe an issue with the pipeline, and down here we have other things coming up, gallons estimated soil product. And I can go further. I can also do a topic analysis. So this does Varimax rotation, so like factor analysis. And I can see themes, in this case 10 themes, which are common themes in these reports. And a lot of this information can be saved, and then it's available for further analysis. So you can really use your unstructured free text information, and you don't need to longer ignore it. So that's really good news we got with JUMP version 13. And there's a lot more, of course, we don't have the time to look into today. And this includes platforms in multivariate platforms, clustering platforms, and a lot in consumer or market research down here. Okay, so let me briefly mention the resources and then wrap up. So for resources, there's really one place to go, and this place is jump.com/teach, and I have it here. And I really recommend to check these resources, which are really helpful for your students, but also for you if you're teaching, if you develop new courses. So there's no greenfield in JUMP. So learning library here, for instance, you get access to one-page guides, videos. So for time series, what we saw, there's a one-page guide, smoothing models. And here you see how to do it and some tips how to interpret the results. So that's called the learning library, perfect for getting started for your students. Now, so we also have a case study library. So these are real problems, real world problems. And one section in that library is about business problems. So here you see business statistics, defect sampling, baggage complaints, treatment facilities, cell phone service. All of these are business statistics problems. You get the problem, you get the data set, but you also get solutions. So this is really a nice assessment or an assignment for your students. Course material library, a lot of information in here, so just check it out. And we collect different types of resources for different types of courses on the left, and business statistics, that's another course coming soon, the course type. But also have a look at the e-learning courses, which are included in a side license, and courseware from SAS Education. So here you get training material. You can also use all the slides and data sets and very nice demos with your in your new course. Yeah, back to JUMP, a different resource are the interactive learning tools. Yeah, and back to JUMP, because they are also available on the JUMP help. If you get sample data and then go to teaching scripts, interactive teaching modules. So here, for instance, there's a module to demonstrate Anova. And then I can draw samples, and you can start here. Show group means, show the ground mean, show mean diamonds. Go on to one-way Anova. Look at the test statistics. Change, get new samples, change one group mean, and see how this influences the Anova output. So these type of modules are really not statistical concepts in your course. And finally, because we are short in time, academic webinar library. So this has some recorded webinars. And here's also one webinar just about resources for teaching and learning. So here you can see a lot more resources and how to use them. Of course, it's also about books. So you already have excellent choices here. And most of them come with data sets, and some of them also with slides. So summary, why is JUMP better for teaching? Why can be teaching better with JUMP? Yeah, because JUMP is different. It's more intuitive, interactive, visual, and fun than any other package. Yeah, and JUMP is about statistical discoveries. It really stimulates statistical thinking and problem solving. And it's not that much about formulas and programming. Yeah, and you get one by all in one package. You also get great exploratory tools, but also consumer research, DOE, and perfect tools for storytelling and communicating your findings. You can also build dashboards and integrate with R, MATLAB, Excel, and other software. Now, of course, it's also about resources, and that's what we said. So software and resources are two sides of the same medal, and we call this statistical discovery. And it's real world. Yeah, you can tidy up messy data easily, and the tools, if it's JUMP, these are industry standard tools. So it and this will tell you how to get your free book copy, market data analysis using JUMP. If you're interested in why JUMP, if you're still interested in that question, why not? Then go to jump.com/why. If you're interested to try it out, go to jump.com/try. And if you're interested to get a license, so the teaching license includes JUMP Pro and all users at a department or campus, but it also includes the e-learning, home use, Windows and Mac, free upgrades, technical support, so everything. But we also have single user licenses for researchers and students. My recommendation is, if you're interested in licensing, just get in touch. So here you see our email address, academic@jump.com, and we are happy to assist you finding the best solution for you. Okay, I'm sorry that we are already out of time. I think if there are any questions, we will handle them offline and get back to them yeah, very soon. So for now, share this with colleagues, or if you want to watch it again, yeah, you will be able to do it. Otherwise, yeah, have a nice day, and thanks for your interest in better teaching of business statistics.